Welcome and willkommen to this section on double angle formulas. We'll do a number of problems, as you can see, using those double angle formulas that I actually may want to borrow from somewhere. So I'm going to get them from all the way up here. There we go, put them in here. Scroll down a little bit. All right. It says for the first one, if sine A equals -3/5 with A in quadrant 3, find cosine 2A and then find cotangent of 2A. And I just have to do a little thing on the side. Open my solution manual so I make sure that I'm going to be correct with my answers. Okay. So, cosine 2A, how do I get that from sine A? Well, it's relatively easy. I can use one of the double angle identities for cosine. The third one, in fact, because it gives me right away what the sine squared of A is. So I'm going to plug that in. It's going to be 1 minus 2 sine squared A. And I'll plug in the numbers in just a moment. So it's going to be 1 minus 2. And then this is -3/5 squared. So I'm going to come up with 9/25. So times 9/25. So I'm going to have 1 minus 18/25 or 7/25 as the answer. Cotangent of 2A. Well, I probably do need the equation editor, so I'm going to do that instead. Cotangent 2A. And then I look at my double angle identities, and there is no cotangent identity. However, there's a tangent to A identity, and of course, cotangent is just a reciprocal of the tangent, so that one will come out to 1 minus tangent squared divided by 2 tangent. So that's what I'll be typing in here. 1 minus tangent squared and 2 tangent A. So a reciprocal. Do I know what the tangent is? Well, I don't know top of my head, but I have a nice Pythagorean triangle right here with the 3 and the 5, which means the third side is going to be a 4. And that's what I'm going to use. So I'm going to take the same fraction here and plug in the numbers. Tangent A, therefore, will come out to 3/4. I have to make sure, is it positive or negative? It needs to be positive because we're in quadrant 3. So this is going to be times 2 times 3/4. 3/4. And then, of course, this one here is going to be 9/16. Okay, what do I have then? I have 7/16, and I'm going to do that on the side here. So I'm going to have 7/16 in the numerator, and in the denominator I have 6/4 or 3/2, which I invert. So I have 7/16 times 2/3, or 14/48 if I didn't make a mistake. Yep, 14/48, where 2 is canceling, so it's 7/24. 7/24 is then the answer. Again, what I just did here, I just did this in my head or respectively on the side. Okay, simplify the following. Cosine squared of 15 degrees minus sine squared of 15 degrees. Well, that again is one of the identities, which I almost scrolled off the screen here. There it is. Cosine squared minus sine squared is the same as cosine 2a. So what I have is cosine 2a. Oops, that was interesting. Cosine. I would like to keep an a there. And then, of course, a is 15 degrees, so 2a is 30 degrees. And that one, I do know, is the square root of 3 over 2. I'll be borrowing that from up there. I think I'll copy this one in here. And there's my square root sign. Sorry about the shifting up and down here. Square root of 3 over 2. Okay, let's see what we're going to do next. 2 cosine squared 105 degrees minus 1. Ooh, that really looks like a double angle identity. It couldn't be thrown at us in any better way. That, of course, comes out to cosine 2a. And for some reason, where it gives me this nice degree sign there, but I like to have my capital A back. So that, of course, is going to be cosine 210 degrees. Reference angle is 30 degrees. So again, I come up with square root of 3 over 2. We're in the third quadrant, so it must be a negative square root of 3 over 2. Okay, sine pi over 8 cosine pi over 8. Well, I'll take the first double angle identity for the sine here, where it says sine A cosine A equals 1/2 sine 2a. Of course, I have to get this 2 to the other side. So it's going to be 1/2 sine 2a. This time I left the a. And then, of course, a is pi over 8. So I'm going to plug that one in. Pi over 8. So I'm going to have 1/2 times sine pi over 4. I know that that is the square root of 2 over 2. So I'm going to borrow that from somewhere. Square root of 2 over 2 with that 1/2 in the front, which will become the square root of 2 over 4. Okay. Tangent 3 pi over 8. Do we have that double angle identity? Yes, we do, right here. However, there is not a 2 in the front. Well, we just divide the other side by 2. That's relatively easy. And then the rest will look like this here without the 2. And of course, it's going to read 1/2 tangent 2a. So here I'm going to have 1/2 times tangent 2a. We plug in the numbers. So I'm going to type in times 3 pi. Oops, so I'm recording myself. I hope I don't confuse myself. The phoning right now, and I try to ignore it. Yeah. Tangent of 6 pi over 4, or 3/4 pi, which puts us at 135 degrees. So tangent of 135 degrees, reference angle is 45 degrees. So we have come up with 1, and we're in the second quadrant, so it's a -1 with the 1/2 in front, so it's going to come out to -1/2. And I'm done with that long problem here. Okay, let's see what else is in store for us. Proof this identity. That, and I better double check that I got that typed it in correctly. Looks correct. Okay, ooh, this one is going to be, I believe this is going to be really, really quick. We have, of course, the difference of squares. On the left-hand side, so we're going to have cosine squared minus sine squared. Equals cosine 2x, and I put the square in here. There we go. And that one indeed is the first double angle identity for the cosine. Double angle identity, and we're done with this proof. Okay. I believe that this is the last one. Yeah, it is. The last exercise here. Prove this identity. And let's see what we're going to do with that. I'm going to leave the sine squared on the left-hand side. I'm going to manipulate what I have on the right-hand side, where I do use a double angle identity. So cosine 2 theta, which one of them am I going to use? I have the choice of 3 here. I perhaps want to choose the third one here because that will give me somewhat a sine squared there, which I have on the left-hand side. So I'm going to say that this one here is 1 minus 2 sine square. And then what do we have here? Theta. So theta. So what I used here is the third double angle identity for cosine. And notice, of course, I put parentheses around this one because there's a minus in front of that. So as I manipulate it now, of course, 1 minus 1 is 0, so the 1 is gone, and then negative 2 here comes out to a positive. So we have a positive right there. Divide that by the 2, and it's very obvious that that is an identity, and we're done. And with that, that one is actually the same. And with that, we're done with the problem section for double angle formulas.